Oops. We're going to solve a system of equations using substitution. This is 2.4.d. In our textbook, the rules say make sure one of the equations has one of the variables isolated, substitute this variable into the other equation, and obtain the value of the other variable through algebra. Quality control is to determine if your solution makes sense. So let's look here at the first one. It says the first step is to make sure that the answer, that one of the variables is all alone, and you notice that you do have x all alone. So we can then substitute what it says x is into the other equation. 8 times negative 5 minus 6y equals negative 64. This is negative 40, so we're going to add 40 to both sides, and we get negative 6y equals negative 24. Divide both sides by negative 6, and we get y equals 4. The other way to do this one is to use your calculator. Mode 5, 1. X is 1. There is no y in this first equation. Oops. There is no y in this first equation, but c is negative 5. Go to the second equation. 8, negative 6, negative 64, and it tells us x is negative 5, y is 4. Let's look at the second equation. Notice that x is all alone, and it tells us x is y minus 11. So let's substitute that in. Negative 5, parentheses, y minus 11 minus 6y equals 22. So I'm taking the second equation here, and instead of writing x, I'm writing y minus 11. All right, problem-solving procedure says that we first off need to multiply out the parentheses. Negative 5y plus 55 minus 6 more y is 22. Subtract 55 from each side and combine these two. I subtracted 55 from each side. This should be 33. This should be negative or positive 3 because it was negative 33. Sorry about that. 22 minus 55 is negative 33. So we get 3 minus 11. Positive 3 minus 11 is negative 8. So x equals negative 8. On our calculator, we would have to first of all rewrite this equation so the y is on the other side. So that first equation would become x minus y equals negative 11. Because the calculator only works if the x and the y are both on the same side. So 1 minus 1 and negative 11. Oops. I gotta get back up there. Negative 11. And the second equation is negative 5, negative 6, 22. And we get negative 8 and positive 3. So let's go to the next ones. Solve these two equations. In the first case, y is negative 4, so we can just substitute that into here, and we get negative 4x plus 6 times negative 4 equals negative 36. Negative 4x minus 24 equals negative 36. Add 24 to both sides. And we get negative 4x equals negative 12. Divide both sides by negative 4. X equals 3, so y is negative 4. Next one. Oh, we should do that one on the calculator first. Let's do that. Mode 5, 1. X is 0. Y is 1. C is negative 4. That's the first equation. Negative 4x, 6y, negative 36. That's the second equation. And we get x is 3, y is negative 4. For the next one, y is already alone, so we're going to write 7x minus 45 in for y in the second equation. So negative x, I'm going to switch colors, negative x minus 4 times 7x minus 45 equals negative 23. So we have to multiply out the parentheses. Negative x minus 28x plus 180 equals negative 23. Subtract 180 from both sides and combine these two. We get negative 29x equals negative 203. Divide both sides by negative 29. Let's see, mode 1. Negative 203 over negative 29 is positive 7. So x is 7. So y equals 7 times 7 minus 45. 7 times 7 is 49. 49 minus 45 is 4. The other way we can do this one is to rewrite it so that it works on our calculator. This first equation would become, put this 7x on the other side, negative 7x plus y equals negative 45. Now we can use our calculator. Mode 5, 1, and we get negative 7, 1, negative 45, and the second equation is negative 1, negative 4, negative 23, and we get x is 7, y is 4. This is the lesson 2.4D, solving systems of equations using substitution.